So very good morning to you all, and now we are discussing today's lecture of quantitative techniques in management and Unit 3. The topic is Hungarian assignment method. So there is a topic called assignment method, assignment problem, and especially we are going to discuss one of the important algorithm, that is Hungarian assignment algorithm. And this is for MBA students. Now, welcome to you all in my class. Let's start the topic. So, as we know in previous classes that what is assignment problem? Assignment is a problem because different people is having different ability to do different jobs. And obviously the cost of performing the job is also different from person to person and job to job. So assignment is a problem because the ability, and here because the ability of different people of performing different job are different. So here there is a question, there is a task, there is a uh, problem before the manager that he has to assign the job to the person and to the job in such a way that the total assignment time or the total assignment cost is to be kept as minimum level. So for solving assignment problem, we have different methods. Like complete enumeration method is one method, although this method is very lengthy, and there are number of feasible solution exist in this method. But we'll not discuss these method here. Although our focus is on particularly Hungarian assignment method. So let's start this method, Hungarian assignment. So let us take one example here. This is algorithm. This is the algorithm, and we're going to apply these algorithm, these steps in the coming question. So for example, this is a particular problem, and this particular problem is having number of workers like A, B, C, D, and E, and there are number of jobs 1, 2, 3, 4, and 5 jobs. So particularly this is a standard problem where 5 jobs are there and 5 persons are there. So this matrix is, you can say, the balanced one. This matrix is, you can say, where is the even one, where the number of rows equals to number of columns, where number of jobs equals to number of workers. So these values, these pink color values, are nothing but the cost involved in between. For example, if person C is allocated to job 1, then he is incurring a cost of 7 rupees like this. Similarly, if person B is allocated to job 5, so in that case he will be involving this will be involving a cost of 7 rupees in this case. So these values are nothing but the assignment cost for a particular job to a particular person. So here the question is, here the problem is, uh, how we can assign the worker to the jobs in such a way that the total time taken to complete all the jobs is to be minimum. But the condition is we have to assign one person to one job, one person to one job. Obviously, there is 1:1 allocation there. No 2:1 and no 1:2 allocation is to be given here. And we have to find out the best suitable combination of person and jobs where the minimum cost involved in between. So let's start the method. Step number 1. To start with the step number 1, step number 1 is row minimization. Step number 1 is row minimization. So as we'll definitely look into these methods later on, but we are going to apply these methods in the question. So first step is row minimization. In this step, we need to subtract the minimum cost element from each row, and subtract this element from the entire row. So in case of the first row, that is A, in case of first row, that is A, the minimum cost element is 2. Minimum cost element is 2. So we have to subtract this 2 from the entire matrix, entire row. So like 8 minus 2 is would be 10 minus 2 is 8. 3 minus 2 is 1. 3 minus 2 is again 1. minus 2 is 0, and 8 minus 2 is 6. Okay, but it is an advice to you all students that you should not cut the numbers like this as I do it here in examination. You have to make a different matrix. You have to make a different matrix here rather than cutting number like this. This is just I need to show you how these numbers is going on. Second minimum, for the second row, the minimum cost element is 2. Subtract this element from the entire row, so that 9 minus 2 is 7, 7 minus 2 is 5, 8 minus 2 is 6, 2 minus 2 is 0, and 7 minus 2 is 5. Similarly, we need to subtract all the minimum element from each row. So in that case, you will be having a matrix like this. So this is the matrix which you will be having after step 1, that is row minimization. So I think if you are doing with me, you can do it like this only. So this is the matrix which is like this: 8 1 1 0 6. So it is like 8 1 1 0 6. So this is the matrix after step 1. Now we are going to apply step number 2. So since step 1 is row minimization, now the step 2 is column minimization. So we need to repeat this particular step for each column also. Like in first column, the minimum cost element is 1. So subtract this 1 from the entire column, that is first column. So the elements would be like this: 7, 6, 4, 0, and 2. Again, it is an advice that you should not cut these numbers like this. You need to prepare another matrix. And one thing is to be clear here, that the step 2 is to be applied on the matrix that is obtained after step 1. Step 2 is to be applied onto the matrix that is obtained after step 1. Okay. Similarly, in the second column, the minimum cost element is 1. Subtract this from the second column. So 1 minus 1, again minus 1, 3 minus 1, and 4 minus 1. In third column, the matrix would be again like minimum cost element is 0. So 0, 5, 3, 5, and 2. But in fourth column, already there are number of zeros available, so there is no change. In fifth column, the last column, the minimum is 2. Subtract this 2 from the entire column, like this. So this is your matrix you will be having after step 2, that is column minimization. It looks like this. Okay. So this is the matrix after step 1 and 2, that is row minimization and column minimization. Now the third step is step 3. Step 3 is what? Draw the minimum number of minimum. Here the minimum word should be underlined, bold, italic. Draw the minimum number of lines to cover all zeros. So we need to draw minimum number of lines. To cover all zeros. So it's like this. First we need to draw, and also it is an advice to you that the line should be drawn. The line drawn should be like horizontal or vertical, but it should not be diagonal. It should not be in diagonal manner. Either it's to be horizontal or vertical. So like first line is like this, because we need to taken care of this minimum word here. कम से कम line draw करनी है ताकि सारे zero cut हो जाए. So first is this one, second is like this one. Okay, go with me, and then like this and this one. So here 4 number of lines are required to cover all zeros. to cover all zeros. Here the minimum word is important because some students do mistake, like they draw all the 5 lines parallelly, vertically or horizontally, but we need to take care of this particular word minimum here. So number of lines required to cover all zeros are 4, and matrix order is 5, which is less than this. So let's see in the next slide. These are number of lines: first line, second line, third line, and fourth line. So 4 lines are required to cover all the matrix. So whenever this number of lines, which is 4 here, is less than order of matrix, which is 5 here, then we need to again move to step 4 here. Step 4. Okay, so let's do with step 4 here. I need to draw this thing. Yes. Now the step 4 is please listen carefully. Step 4 is select the minimum uncovered element. Select minimum uncovered element. Minimum uncovered, which is 2. जो कटे नहीं है उनमें से सबसे मिनिमम कौन सा है? Minimum uncovered is 2. Subtract this element. Subtract this from all uncovered and add this number at each intersection. You know intersection is what? Intersection is the intersection of row and column. So minimum uncovered element is 2. Subtract this element from uncovered. So it would be like 4. It would be like 3. Then 2 minus 3, 2, 0, and then 1, 0, 1, and 0. So subtract this element 2 from each uncovered and add this number at each intersection. So intersection like this. Here we need to add here. So 0 plus 2 become 2. This is also an intersection. 2. This is also an intersection. Add here 2. This is also an intersection. Add here 6. So subtract this element from each uncovered and add at each intersection. Okay. So this is to be done. This is step to be done whenever you are having number of lines is less than order of matrix. But if number of lines is equal to order of matrix, then this step doesn't require. You can directly assign jobs to the workers. Okay. Again, you have to this matrix is look like this. This matrix is look like this one. Now again draw the number of lines. Again draw the number of lines to cover all the zeros. So draw it carefully. Start with the line which is having maximum number of zeros there. So first line, 3 zeros cut. Then you would be having this line, 2, 3, 3, then 4, and then 5. So number of lines. How many number of lines required here? 5. And the order of matrix is again 5. So this is equal. Now we can start allocating assignment. So assignment allocation is to be start only when you would be having number of lines equals to order of the matrix, and the order of matrix here is 5 by 5, and the number of lines is again 5. Now we can start allocating the jobs to the person. So how it's to be done? I need to erase these lines here so that you can clearly see what is happening here. Okay. Now this is a situation where number of lines equals to order of matrix, and we are going to assign the jobs. So assigning is possible only at the zeros locations, because here we don't have any, don't lose any opportunity here. So start with the zero which is having unique zero in their row and column. So is there any single zero is there? Yes. In column B, there is a single zero. Allocate this person to the job 4 and cut these 2 0 of this particular column. Since in second row, this zero is the single zero, unique zero, obviously we have to assign this particular job. So what is to be done? Worker B is allocated to job 4, because there is a condition in Hungarian assignment method that we can allocate one person to one job only. In that sequence, we are going to cut these 2 zeros, because the job 4 is already allocated to person B. We cannot allocate this job to any other person. Okay, now any other single zero? Any other single zero anywhere you found? Yes, in fifth column there is a single zero. In fifth column there is a single zero. Assign this particular job. And as soon as you assign this person to this job, this particular zero is to be cut. This cut signifies that you should not assign here any job by mistake. That is why I'm going to cut this particular zero. Yes. Now any other single zero remaining? Any other single zero remaining in any row or any column? Yes. In fourth row, D row, there is one single zero, and you assign this particular job to job 1. Person D to job 1. And you should cut this particular zero. As soon as you cut this zero, E, in the last column, the last row E, there is 1 0 remaining, and you should give this particular job to worker E and cut this particular zero, so that you should not make 2 boxes in any row or any column. Now in first row, only single zero remaining, so assign this particular job. Yes. Now this is the you are going to the solution of this particular model. Person A is allocated to job 2, B is allocated to job 4, C is allocated to job 5, D is allocated to job 1, and E is allocated to job 3. Okay, so this is the assignment, optimal assignment rather, which is obtained after using Hungarian assignment method. So this is look like this. This is the assignment. Obviously 5%, 5 job would be having 5 assignments, and please keep in mind that no single row or column is having 2 assignments. You have to taken care of this particular law, this particular rule, that one person is allocated to job one job only. Okay, now what is the cost involving in this particular method? So you can see, you can compare this particular location from the original matrix, and you can see the original matrix is having values at these places like 3, 2, 4, 3, and 9. So if you add these values here, so your answer would be like this. Worker A is allocated to job B. You should draw this particular matrix while showing your answer. Cost involved is 3. Person B, job 4, cost 2. Person C, job 5, cost 4. Person D, job 1, cost 3. And person E, job 3, cost 9. And the total cost involved is 21. Total cost involved is 21. So using this particular method, 5%, 5 jobs, you can see this is the allocation. And obviously we are going towards the optimal solution of this particular method. And now you can read this particular algorithm so that you can revise what we have done. First of all, using the Hungarian method, First of all, you need to perform the operations like row minimization. After that, column minimization. Step 2. Step 3, draw the minimum number of lines to cover all the zeros. Lines must be horizontal or vertical. If the number of lines is equal to order of matrix, directly you can jump to step 6, that is start making allocations. Otherwise, if the number of lines is less than order of matrix, then you should subtract the uncovered element, like as we have done in this particular question, and repeat this procedure till we get number of lines equals to order of matrix, and then make assignments and find the total cost. And you imagine in this particular example, since we are having a matrix of 5 by 5, there are 120 possible solutions are there for this particular problem. 120 factorial 5. Factorial 5, that is 120 possible solutions are there. 120 feasible solutions are there. But out of those 120, only one optimal solution, which involves minimum cost, and that solution is this one. Okay, so this is how we can solve a particular matrix of workers to job, clerks to counters, machine to operators, so that the total assignment cost is minimum, so that the total project cost is minimum, and this is your optimal solution. Optimal matlab means best solution. This is the optimal solution, and you can see out of 120 possible solution how easily or how quickly you reach to this particular optimal solution. So I think students, you understand this particular method, and today it's all from my side. We'll be having another examples and other questions in next class, in next video, and hope you understand this. And you should it is my advice that you should practice these questions. You should practice these questions so that you would not be facing any kind of problem while solving this particular question. Thank you. Goodbye.